Hi, this is Chris Schomburg, and I'm your instructor for robotics. Now, what I'm going to propose today is actually a challenge that I've done with NXT programs, and you've actually seen it with the virtual robots already. But what it is, it's basically the same challenge. It's called the Labyrinth, and I've actually built it here. In this case, I used very inexpensive materials, built it in real quick fashion. Basically, it's just cardboard with tape. Instead of being 4 by 8, in this case, this is 4 by 2. So this is 2 feet in this direction and 4 feet in this direction, instead of the 8 feet by 4 feet, which is on the specifications of the NXT model, Labyrinth. Now, this Labyrinth here, I want you to kind of think about what are going to be some of the design challenges that I'm going to have to overcome to encounter and to solve this Labyrinth problem. Now, you're going to start with your robot right here. So this is my MBot. I'm going to put my MBot right in here. I can pass through this first line, but beyond that, I'm not supposed to touch any of these black lines here. Can't touch any of them. Can't touch any of these lines. Can't touch these lines. But I have to actually traverse, so somehow from here to here, and I have to get to that point right there. So that is really the challenge, is to try to get from this point to this point with programming, and to actually program it to do that every time. So it's one thing to do it once, it's another thing to do it every time, and to do it pretty much on command. So that is my goal for you. That's kind of what I want to think about. Now, let's take a pause, and let's actually think about what are some of the design challenges that go into this. Well, one, so we know we're going to have to go forward at some point. We know we're going to have to go to the left at some point. We know we're going to have to do a 90-degree left-hand turn. We know we're going to have to do a right-hand turn with 90 degrees. We know we're going to have to go forward. And then we know we're going to have to take another right-hand turn and go forward as well. So that's basically the basics of what you have to do programming-wise. Now, the trick is to really use the design process and use the scientific method, which is to do one step at a time. Now, you could go ahead and blow out and try to put all of the steps in right away because you're that confident, and you'll find yourself actually taking a lot more time doing that than if you were to take one step at a time. So let's say, let's go forward. How far do I have to go forward? Well, I have to get my robot from here to about here. Okay? So that is one task, right? So there's one step. Then the next step is, okay, now I've gotten that far. I need to actually now turn, right? So that'd be 2 steps. Okay? Then I have to go ahead and I have to go forward. That's 3 steps. Then I have to go to the right. That's 4 steps. Then I have to go forward. That's 5 steps. And then I have to go to the right. That's 6 steps. And then I have to go in, which is 7 steps. So sequencing it actually breaks it down into a lot simpler problem. Now we know we actually have just 7 steps to go ahead and to meet the challenge of the Labyrinth. Now, you could have gone ahead and programmed all those sequence of steps all together at once, but like I said before, you're likely going to come up and fall short at some point and have to redesign the whole thing every single time. It's too many variables to have to solve. Well, I hope you had that, and I hope you liked the Labyrinth challenge. Go ahead and try to do the best you can with that.